Friends, welcome to my YouTube channels. Today I am going to discuss the nozzle problems, convergent divergent nozzle problems with the Mollier diagram method. So before also video I explained. Now again I will show the Mollier diagram and how to solve these questions we'll discuss today. So what is the questions given here? Dry saturated steam at a pressure of 8 bar enters a convergent divergent nozzle. So this is the convergent nozzle. 1 to 2 is convergent nozzle. What is convergent nozzle? Area of the cross sections gradually decreases from inlet to throat. Middle section is known as throat. And 2 to 3 divergent part. So this is given convergent divergent nozzle. And exit pressure or leaves at a pressure of 1.5 bar. That means the P3 given 1.5 bar. And P1 is given 8 bar. If the flow is isentropic, what is meaning of isentropic? If flow given isentropic, that means this entropy will be constant. This is the Mollier diagram I drawn here. This side enthalpy, this is the baseline is entropy. So entropy will be constant when the steam flow isentropic. So entropy will be constant. So S1, S2, S3. Now they are asking find the ratio of the cross sections area, exit and throat. So A3 by area of A3 by A2 they are asking. Conditions they given maximum discharge. Why the maximum discharge given? Because P1 given, P3 given, P2 not given. So some mistakes, what mistakes they will do? This leaves at pressure 1.5 bar, they will take the P2. But what this language here? Now at leaves at pressure 1.5 bar. Means leaves from outlet. So they given P3. So P2 we have to find out. They given for the maximum discharge. We know the maximum discharge, that critical pressure ratio P2 by P1 equal to 2 by n plus 1 divided by n minus 1. Divided by n minus 1. This is the critical pressure ratio for the condition of the maximum discharge. Now if you substitute all the value will substitute. P1 will be given 8 bar and they given already 1.135 plus 1 power they given n is 1.135, then 1 minus 135 minus 1. If we'll solve here P2 and we will multiply this 8, P2 will come, already we calculated 4.6 bar approximately. 4.6 bar, some decimal number will be there. So approximately we taken P2 is equal to 4.6 bar. So we got here 4.6 bar we got P2. Now P1, P2, P3 we know. So in the Mollier diagram method, what we have to do, we'll see from the Mollier diagram, enthalpy H1, H2, H3, how to solve, how to see, that I will show you now. So first you understand this is line diagram. In exam you have to draw this diagram in your notebook. So this is the enthalpy, this is the entropy, this is the saturation line where dryness fraction is 1 because this is dry saturated line. Below this line will be wet steam, moisture content steam. So dryness fractions will be less than 1. Above this line will be the superheated steam. How we know the superheated steam? Suppose 8 bar and 200 degrees Celsius, 150 degrees Celsius, anything temperatures they given, then above this line you will see this 50, 100, 150 like temperature will be there. So that time these conditions will not come. One conditions will not come. So that will be the separate problems. When we will solve, we will discuss this. So now this particular problem they given dry saturated system. So first point will be in the saturation line. So saturation line, if you will see from the Mollier diagram, this pressure P1, always top one line will be there. Their pressure you have to bring from there. Here also in this line pressure will be there, but very close value will be there. So what you have to do, see this from 8 bar top, if you'll see the Mollier diagram, 8 bar, then you have to bring that line where this point will join, draw the horizontal line, will be the H1 will see. Again, draw the vertical line, then P2 P2 already we got 4.6. So we can write here 4.6 bar, and this is the given 1.5 bar. Okay, 1.5 bar, this also bar. Okay, I'm not writing. So this way, when P2 will take 4.6, suppose 4 and 5 will be there. 4 and 5 will be there. Then you have to take this line approximately with respect to 4 and 5. You have to draw the curve line, and where this point will join, from 1 we draw the vertical line, this will be the H2. Draw the horizontal line, will get 2650. Similarly, again we'll take 1.5, again that line, inclined line, you bring here, and where will join this vertical line will be the H3. So H3 we wrote 2465. Now this is the X1. Once I told already, this below this saturation line will be the wet steam. So dryness fractions will reduce gradually. It will come, dryness fractions will reduce. So X2, like this inclined line will be there. Lot of lines will be there. This is dryness friction line. We see this point and this line were actually matching. So this we got 0.965. Similarly, X3 0.902. So how to see this? One trick also is there. Suppose one value to another value. Suppose 2400, 2500. This value will be there 100. So here you will see that 10 box will be there. 10 box will be there. Each box contains 10. So once you draw either a scale, or in this point you see this thick line either above or below will be there, thick line. That line will know how much is value. From this line will count how many box, 1, 2, 3 here, and here reaching above, either above or from the below. Then you count, suppose 1, 2, 3 lines. So 1, 2, 20. So we'll reduce 2480. Suppose half. Then 2485. Like this we'll see. So like this we'll approximate. As we know, Mollier diagram method is approximate method. Exact method will be the steam table method. So, but if they are asking solve the by Mollier diagram method, you have to solve, and that much liberty will be there to value will come, little exact value, different value will come. Okay. So this way we can take. Now I'll show the Mollier diagram. I will try to show the Mollier diagram. Already we explained there. So this is the Mollier diagram. This is the Mollier diagram will be there. You see here. This side is the enthalpy. This side is the enthalpy. Bottom you see this entropy. Bottom line will be the entropy. Now you are seeing here the thick line will be the saturation line. So already told this line itself X equal to 1. Below this wet steam, above this superheated steam. So you can see here all the temperature will be there. And already I told here pressure will be very near value will be there. So you have to bring the pressure from this line. So what this I told here one line will be there. So in this line 8 bar you have to bring here, that is curve line. How this line is coming? So you have to bring here 8 bar. Then you see this horizontal line. See this thick line is there. So you will see this line how much below, all 100 distance. Now we have 10 box. Each box contains 10. So like this you can count, or you see from the scale also, and draw the vertical line. Bring this pressure, So like this pressure you have to 1, 2, 3. Then see dryness fraction line. This is saturation line. This is also dryness fraction X equal to 1. Below this lot of line is there, thin line is there. See, thin line is there. Now value you will see 1. Here you will see the value 0.95, 96, 97, 98, 991. So each having 9596. So where this value will come, you have to approximate and you have to write this dryness fractions value. All. Now a specific volume we need also. A specific volume we need not, that I will tell you the trick how to see. But if the Mollier diagram you should know, you will see this dotted line will be there. You are able to see here dotted line will be there. Dotted line will be there. In between this, suppose this point is here, 2 dotted line. How will approximate? That will get the Vg2 value. So that value, what will do here, very difficult to see exact value. So from the steam table we will see and will approximate the value. That I will explain you now. So this is the Mollier diagram. You know this, based on this diagram, try to understand the color molar diagrams you use, and you see this value. 1-2 times you practice, it will be very, very simple. Okay. Now we are going to solve the question. So now you see here, we know the pressure P2. We know the pressure P2. Now, how to find the exit ratio of the exit and throat? So now from the molar diagram method now, so P1 will be there. So from the molar diagram, P1 at 8 bar, we got H1 or Hg, how much? 2770 kilojoule per kg. Similarly, H2 we got 2650. Then H3 we got 2465. We got this value. Now, what is the mass flow rate? Mass flow rate is equal to A2 V2 by specific volume V2. This is A2. Mass flow rate equal to. So mass flow rate will be always constant. So you can see now A V by specific volume is equal to constant. That means A2 V2. Then again A3 V3 by specific volume V2. We can write this. Why I not wrote A1 V1 V2? Because initial velocity of the steam will be negligible. If not given initial velocity, we have to assume the initial velocity will be negligible. So from this formula, we will get A2 by, they are asking A3 by A2. A3 by A2. Now A3 by A2. So what will be the V2? This is V3. This is V3. So V3, A3 by A2. So V2, V3, then V3, V2. V3, V2. Now look at again. I need A3 by A2. So V2, V3, V3, V2. That is, this is the velocity of the steam. This is the specific volume. This is V2, V3, the velocity of the steam. So we have to find out this only. Then what is unknown here? You see, V2 and V3 will be the unknown. So what is V2 formula? Now write 44.72 H1 minus H2. We'll substitute this value here. 44.72 H1 and H2 value will substitute. 2770 minus 2650. So you will get the V2 here. So how much V2 we calculated already? V2 will be there 489. V2 will be there 489.9. 489.9 meter per second we got. Similarly, we will write V3. Same formula will be there 44.72. 44.72. Here H1 minus H3. Substitute value will substitute 44.72. H1 will be 2770 minus H3 will be 2465. If you will calculate, you will get the V3. This you give the equations number 1. Now you get the V3 here. So how much V3 we calculated? V3 will be 781 meter per second. 781 meter per second. So now you know the V2, V3. Now what we'll do is specific volume already I told. So specific volume Vg2. Vg2 at 4.6 bar. We'll see from the steam table. If we'll see that from the steam table. Just I will show you. One minute. So steam table will see the steam table. So we'll need the 4.6. This is temperature base, temperature base, pressure base is started. So we need the Vg2. In this point, what is the Vg2? So specific volume 4.6. Now if we look here, 4.6 is there. So directly 4.6 will be the Vg. 0.40526. I will see how to write. This value will not take a Vg2 0.40526. This value we taken from the steam table. But this value we can write because once you are solving the Mollier diagram method, we cannot write this value. And here also you will see the dotted line will be there. You have to approximate. We have seen you cannot see this like value. So this value what will approximate like a 0.42 or 43 like this we can approximate or 0.41. So suppose I am taking here point. How much value I taken for my calculations? 41. So this you take 41. Then that means this value looks like we taken from the Mollier diagram. So this I am taking here 0.41 at 4.6 bar. Then, so you understand again, this value taken from the steam table. This value taken from the steam table at 4.6 bar. And we approximated it. So it looks like we taken from the Mollier diagram. Okay, now again Vg3 specific volume at 1.5 bar. 1.5 bar. This also will take from the steam table. So 1.16. So this value 1.6. How much value is there? I will see. Then I will approximate. I will tell you. 1.159 is there. 1.159. But will not take this same value. So what will take this value? 1.16. So what will approximate here? 1.16. This value we taken from the steam table. So we approximated this value. Meter cube per kg unit will be there. So this value will take 1.16 Vg3. So V2 you know, V3 you know, Vg2, Vg3 you know. Now specific volume. Now I am writing here specific volume Vt formula is Vg2 into x2. We'll get the specific volume. Specific volume 3 is equal to Vg3 into x3. This value will calculate. So what is Vg2 here? I taken 0.41. 0.41. What is x2 here? 0.965. We'll get some value. Here also you'll write Vg3 how much taken? 1.16 into 0.902. Both value will write. We calculated already. So both value will be right here. Vg2 0.41. So this value coming 0.3957. 0.3957 meter cube per kg. So we are not writing unit due to the space problem. So 1.0463. This I know all the value. Now what will do? V2, V3 specific volume for throat and exit will substitute in the equation 1. Substitute all the value. What is value? Steam velocity at throat, steam velocity at exit, Vg2 and Vg3 in equation 1. In equation 1. In equation 1. So what we'll get here? A3 by A2 equal to, I will write one times value, V2 will be 48. So this V2. So V2 how much? 489.8 into V3. V3 1.0463 divided by V3. V3 we have 781. 781 into what is V3? V2 0.3957. So if this will calculate, this if you will calculate, you will get the value 1.6 or 1.7 something. So 1.7, approximately 1.7. This is the ratio they are asking. What they are asking? Find the ratio of the area of the exit and throat. So this way we can solve this question. So listen again what we did. If Mollier diagram value, the Mollier diagram method they are asking now, draw this from your Mollier diagram, take the H1, H2, H3 value, X2, X3 value you take. As we know mass flow rate is constant. From there A3 by A2 we calculated. Then what is unknown? Our V2 and V3. Formula will be this one and we'll calculate the V2, V3. Then we took value from the steam table and approximated this value, because here we can say na it will take time, and we substituted the value, we got the area of the exit and throats. Okay students, watch this video carefully and practice this, keeping the Mollier diagram, practice this, share this video to your friends. Okay students, thank you.